Hello students, for class 12 today I am going to give you the explanation for the remaining part of function, inverse function. Now let us discuss inverse function. A is a set and B is a set. Then for function we know it is a correspondence or a rule which associates the elements of A to the elements of B. Elements of A is X, there is X belongs to A, and elements of B, which is Y, Y belongs to F of X, that is Y belongs to set B, Y is equal to F of X. So what do you know? Let F be a function which is 1, 1 and onto from A to B. So we get two features or characters of the set, that is 1, 1 and onto. From set A to set B. What does it mean? Every element of A has its distinct image in set B, whereas every element of B has at least one image in set A. The forward is 1, 1, the reverse one is onto, that is onto whenever B to A. Let Y be an arbitrary element of B. Since F is onto, what does it mean? Therefore, there exists an element X belongs to A such that F of X is equal to Y. That is, in this function, if we are putting the value of X, we will get the value Y. There exists a unique element A belongs to A such that F of X is equal to Y. Okay? There exists a unique element X belongs to set A such that F of X is equal to Y. So we may define a function denoted by F inverse, because if this is X, then this is F inverse. Clear? Now in the inverse function, I mean the reverse function, if we are putting the value of, if we are putting the value of Y, we will get back X, because for X we get Y. So F inverse is a function which establishes a relation among the elements of set B to set A. So in the reverse function, F inverse, it is a function from B to A. Now F inverse Y, that is, in the inverse function we are putting Y. So F inverse Y, we will get what? X. So what we get? Whenever F of X is equal to Y, X is equal to F inverse Y. Conversely, you can say, if X is equal to F inverse Y, F of X is equal to Y. Thus, the function F inverse is called the inverse of F. When F exists, its inverse function may exist. Now, another definition of inverse function. A function from A to B is defined to be invertible. Now what is invertible function? Invertible function means if the inverse of the function exists, then it is called the invertible function. Now, when the inverse of a function exists, inverse of a function exists means it is 1 1 and at the same time it is on 2. So whenever a function is both 1 1 and on 2, the inverse of the function exists and it is called the invertible function. So if we are to show that a function is invertible function, then we have to show that the function is 1 1 as well as on 2. Okay, whatever may be, a function f which exists from a to b is defined to be invertible, means both 1 1 and on 2, if there exists a function g which establishes a relation from b to a. So g is a function from b to a and f is a function from a to b, such that g of f is equal to ia. G of f is equal to ia. What does it mean? G of f is equal to ia means in the function, if we are putting the value of x, we will get y. Now in the reverse function g, if you put y, you will get x. So g of x, that is when both the functions works together, if we operate both the functions for x, we will get back x again, that is identity function. And f of g is equal to ib. The function g is called the inverse of f and is denoted by f inverse. A function f is invertible if and only if f is 1 1 and on 2. Now here to be noted that domain of inverse function is equal to range of the function. Range of inverse function is equal to domain of the function. Inverse function exists when f is invertible. When the function is invertible, invertible means what I have said, that is both 1 1, both 1 1 and on 2. Clear? So if you were to show that the function is invertible, means you have to show that the function is 1 1 as well as on 2. Now inverse of inverse function is equal to the original function, the function itself. The identity function ia, it is a function from a to a, is clearly bijection and hence is invertible. Moreover, ia inverse is equal to ia, that is inverse of identity function is the function itself. Next, two very important proofs. Actually these are the theorem. Let f is a function which exists from a to b, that is f is a function from a to b, be an invertible function. Then we have to show that f has unique inverse, that is inverse of the function is unique. How to show this? Let, if possible, f has two inverse function g1 and g2. g1 and g2 are two different inverse of f. Then for all y belongs to b, if we are putting the value of y in g1 or in g2, we will get x. That is f of g of y is equal to ib y and f of g2 y is equal to ib. So what we know, f of g of y, f of g1 of y, so f of g1 y is equal to f of g2 y. Now taking the inverse of the function, f will remove, so g1 of y is equal to g2 y. It implies that g1 is equal to g2. So it contradicts that G1 is not equal to G2, because if G1 and G2 are two different functions, then it should not come G1 is equal to G2. It means G1 is equal to G2. Next, another theorem. Let f is a function from x to y be an invertible function. So x to y, the function is f, which is invertible function. Then we have to show that inverse of inverse, that is inverse of f inverse, is equal to the original function f. That is f inverse inverse is equal to f. Let these two proofs are very, very important. Many times these two questions appear in different board exams, that is in HS board exam, in class 12 board exam. Let f be a function from x to y, be an invertible function. Then there exists a function g which is from y to x, such that g of f is equal to ix and f of g is equal to iy. Now here f inverse is equal to g. It is because if this is f and this is g, actually this function is the inverse of this one and this function is the inverse of this one. So this, if this is f, but then this is f inverse, but we have said this is g, then f inverse is equal to g. Now g of f, what we know, g of f is equal to ix and f of g is equal to iy. Now what is g? G means f inverse. So for g we will write f inverse of f is equal to ix and f of f inverse is equal to iy. Hence f inverse is a function from y to x, is invertible, and f is the inverse of the function f inverse. That is, inverse of the inverse function is equal to the original function. Okay, so these two theorems are very, very, very important. Students give special care for this chapter, relation and function. Now there was one part, binary operation, which is deleted in the new session 2021 and 1920. Okay, from 1920 and 2021 this part is actually deleted. Okay, so for relation and function we have completed the explanation of the chapter. Now students, you should go through the exercise, should try to do the theorems very well. Composite function, inverse function, these are very, very important. Okay, then try to solve the exercise of the NCERT book. Okay, so far today.